Hey, hello, and welcome to the show. It's me, JP. It's time for JP's workshop, John Park's workshop. That's what I call myself here. Hello, and thanks for stopping by over in our chats and just on video if you're just watching. If you want to get involved with the chat, you can check out the YouTube chat. It's this right here. Hello to Dave Odessa. Thanks for popping in. It's just Dave now, but I'm sure some others will join. And then our Discord chat is the other place to check out. That's it right there. You can go to adafruit.it/Discord, and you can join into the live broadcast chat channel, which you see right there, along with these good people, Andy Calloway, Sam J. Ohio, hello, Paul Cutler, Jim Hendrickson, Thin Man, Dan Coliano, howdy. I didn't clean off these glasses, and they're... You'd be surprised how much glare I get with the lights and smudge and stuff on these things. So let's clean those off. So yeah, we're here. We've made it this far. Thanks everyone. It's Thursday. We can check out some fun stuff, play around with some projects. I've got a coupon code for you if you want to save some money in the chat. I have a recap of the Tuesday show, my product pick of the week show. What else? I've got a CircuitPython Parsec for you, continuing with our, almost got it, with our new series on character LCDs. I'm going to touch on a few projects that are in process, as well as a new mega project that's going to be creeping up here and seeping into my entire life and personality and all that I do. It's a pinball machine. And I'm actually going to use that today just to talk about a bit of a Claude project. We were talking the other day, and Lamore asked the creative engineering group of us to maybe highlight weird uses of your LLM of the week. So I've got one it's not too far out there, but it's certainly an interesting one, I think. What else? That should be it. I think that'll be it. So as promised, I've got a coupon code for you. That right there. Scrolling. I keep them scrolling. Scrolling. S-C-R-O-L-L-I-N-G. Scrolling. Scrolling will save you 10% off in the Adafruit shop today on anything that you can buy that we can send to you. So we don't have a discount on gift certificates or subscriptions or software, but for physical things that we can send to you in the mail, that'll give you 10% off. If you head over right there, look, there's Adafruit, and you've got some new products. Actually, this one is kind of cool right here. Interesting. Adafruit 128 by 64 RGB matrix display. I don't have one. I haven't tried it yet, but it's interesting because when I built my wall mount Pico 8 Raspberry Pi wall art video game arcade, that was 4 of our 64 by 64 pixel displays, and this would probably simplify the wiring. I'm assuming that we've got code that would allow us to do that. I'll talk with Foamy Guy. He did a lot of the sort of frame capture stuff to work with those other displays. But this is interesting, 128 by 64. A lot of times that's what people want. They'll get two 64s, put them together, mount them on something, and then make a nice weather station or clock or something. It's nice and dense. You can do some good looking stuff on it. So this is a new one that we've got here, and that's of course just one of many things that you can check out in the new products section. We have this 4-color e-ink display from Pepperoni that looks really neat. I think the discount works on that. You'll get 10% off. You can check out, we've got a bunch of different sensors that have come out lately. Some of them I've done recently on Product Pick of the Week. Some of them will be upcoming on Product Pick of the Week. But if you want to get it now, if you can't wait, no promises, if you can't wait, get 10% off. So that's the coupon code right there, scrolling, and that is going to save you money today. Let's see, over in our YouTube chat, I noticed Netventive showed up. Hello. Thanks for stopping into the chat. And also over on Discord, John Nodge, howdy. C. Grover said every day is the start of a 3-day weekend. That's because, who said this? Andy Calloway. Let me bring up the chat. Andy Calloway said, get rid of that coupon code there. I'm retired, so every day is the weekend. Hey! Goals. Scrolling, ride. Scrolling, yes, that's right. That was the coupon code. Next up, so I have the Tuesday show, and that is that right there. That was the one this week, and here's a little recap of the product pick. That right there is the product pick of the week this week. It is the Max 44009 Lux sensor. This is an easy-to-use Lux sensor that has a really wide range. So it's a 22-bit dynamic range from 0.045 lux, really, really dark, all the way up to 188,000 lux. And I'm displaying the lux value there. Right now it's 146.9 lux. Turn off this light right here. It's going to drop down. Okay, we're at 55.1. Turn that on. We're going to go right back up to the 146.9. So I'm at 8,617. That one's got pretty fresh batteries. Here's a different light here, dimmer batteries, and up to 3,000. Product pick of the week this week, it is the Max 44009 Lux sensor. Oh my gosh, it got bright there at the end. That's right. That was it. That was product pick. What are you going to use yours for? I think we sold a bunch of those, so I'm always curious what people are using those for. I mentioned the flashlight thing. I at one point years ago, I was looking for a flashlight, and I came across some sort of, what's it called, the Firepower forums. There was a very dedicated EDC carry, crazy bright flashlight community, and they had some standardized tests where they would set the flashlight a meter or something from their lux sensor, check the brightness, then also check the diameter of the spill, the penumbra, the umbra, fall off, all that stuff. So this could be that kind of sensor you want for that sort of thing. Who knows? Maybe your iPhone will do that these days. I'm not sure. Hey, speaking of things I am sure of, I'm sure that it's time for CircuitPython Parsec. CircuitPython Parsec. Okay, believe it or not, I'm still using Z for this, but I'm not trying to do anything fancy like open 2 tabs. So, small update on that. Todd Kurt said that he discovered the Atom team, or I guess those from the Atom team who didn't go to create Z went and created Pulsar. So that's another alternate I hadn't heard of, another alternate code environment that I might check out. But that's not what we're here to talk about. We're here to talk about, for the CircuitPython Parsec today, I want to continue with our series on character LCDs. In this case, I have the character LCD shield, RGB character LCD shield for Arduino and other Arduino-shaped boards. I happen to have this on a Metro RP2040 right here. And what I wanted to talk about is the buffer, the character buffer that we have, and moving that buffer around. So in the case of this particular display, this is a 16 character by 2 row display. So we can fit 16 characters across, we can fit 2 rows of text on here. However, that's not the full story. There's actually in the character memory, the RAM on here for the display, there's actually room for 40 characters. So it's, you can think of it like a 40-column text card in the old like Apple computer days. So we can actually fit 40 characters on there. And one way we can tell this is by simply moving the display sideways. I've set up these buttons here to move my display sideways until we loop back around. So if I hold this, you'll see we'll eventually scroll right back to the beginning of the 40 columns. To make this a little easier to see, I've got a button here that's going to type in 40 characters. So I've got the alphabet, some numbers, and a few character punctuations, I should say, or symbols here. And you'll see that if I just scroll to the left one, oh look, there's the loop around point of the 40th character. So that is using the character LCD library with the scroll left and scroll right command. So you can use this for a lot of neat effects. I'm just using it in this case to demonstrate the character buffer. So if you look at my CircuitPython code here, you can see I'm importing the Adafruit character LCD.character LCD RGB I2C as character LCD. I tell it it's got 16 by 2 as the size of the screen, and then I'm creating an LCD object on the I2C bus here that has all of that info. Then I clear it, and if I go ahead and reset this now, you'll see what happens at the start. We clear the display, I set the cursor to blinking, and then I put the color to yellowish green. Then I'm setting the LCD cursor position to 0, 0. That's actually the default. I'm waiting a few seconds, and then I'm typing. So that's why we see the little blinking there, which is sort of a built-in routine on the display memory. Then in my main loop, you can see I check for the buttons. If I move this left button, then I'm moving the character buffer over to the right, and that's just to represent the way sort of arrow keys work on a computer. Opposite for moving the right button, we'd say LCD.moveLeft, so that just takes everything that's on the screen and slides that around within the buffer, the 40 character buffer. And then my bottom one here is what types in this message. So I go to the first position, 0, 0, and then I type in ABCD through the 40th character there, and I just turned off blinking at that point. So you can see our full scroll there as we run through the character buffer. And that is how you can use the full 40 characters of the LCD character displays buffer inside of CircuitPython. And that's your CircuitPython Parsec. I just noticed over in the chat a beautiful Arduino cake. Where's the Discord here? Todd said Arduino-shaped boards. That is, yes, technically Arduino-shaped. It's board-like. It looks delicious. I kind of want that icing. Can you imagine the color of your tongue? Well, you can. It's going to be that teal-y, cyany, teal-y color. Todd said he had a couple of 2x40 character LCDs. 2x40. Did I say 2x40? Long display. In fact, if you're interested, I'm going to continue with some other things on this display just because I like it so much. I don't believe we have any sort of provision for rotating that inside of the CircuitPython library, but the character, there's a command that will allow you to essentially place all 7x4 or 7x5, I think it's 7x5 dots per character, so you can make your own interesting little emoji and things like that by specifying down to the individual pixel of the LCDs. So maybe one day that dream will come true, Todd. Oh wait, do I dare click on this? Let's see. Let's see what happens. Oh, 2x40. Oh, I see what you're saying. Yeah, 40 wide by 2 high. It's the full 40. I see. I see what you're getting at now. That's really neat. Thank you for clarifying that. See, a picture helped me so much. The words confused me. That's pretty neat. Now I want that. Really want a 40 by 1. Just Sliver. 80 by 1. Can we have these things? I hope so. All right, thanks, Todd. Thanks for that. Next up, let me double check my chat there. Good. So, a couple of projects in the works right now. First one, I went over this a bit on the show and tell last night. I've continued to develop the Bluetooth sniffer here, or scanner. I'm calling it the Cluetooth scanner. It's a Clue. I've printed a lovely little case from the Ruiz brothers. And you can see here, I'm touching one of the cap touch pads from the back there. So I can, can I do this backwards? I can change my filter. In fact, let me go to the down shooter for this, because that's a much easier way to do it. I can go and scan the air for all the Bluetooth there is. Right now I'm getting 15 things, and I'm sorting them by signal strength. I can advance through my list with the little number 2 cap touch pad on the Clue there. FS60B turned on as well. That's another of my sort of video lights. That's funny. I hadn't seen that one come on before. Is that right? I don't think that thing had Bluetooth. The things you learn. Let's see what the details on it say. Anything interesting? Seen 510 times. Services. I may be able to look up what that service is, or it may be a mystery service. I would guess there's probably a remote that, this is Godox is the brand. It's the Godox. Oh wait, am I on a different one now? Let's see. Yeah, FS60B. Is that? Maybe someone will Google that for me. What is the FS60B? Are you that light? It might be that light. Do I dare check? I think I dare check. Hold on, I'm gonna go to my browser behind the scenes here and check. FS60B. Sure is. Oh, no, that's the NAND light. So what's the ZVE10 then? ZVE10. Oh, it's this camera. Okay. The new light. Okay. The Godox is not in there. This is, this happened last night during the live stream. It'll probably just correct itself after 20 or 40 seconds. I think every 20 seconds I have it refreshing, and sometimes it runs into a memory overrun, buffer gets full. So let's give it another cycle to see if it clears itself up. Nope. It'll still, I think, accept commands even. So you can see, actually, that's a very fast flip through the different filter categories that I have. Let's just leave it. I don't want to restart it because I want to see if it's able. It should be able to recover. I'm not quite sure why it's taking multiple tries. Let's see. Is it going to recover? No, it's not. All right. Last night on the show, I think I kept talking for like 2-3 minutes, and then I noticed that it had come back. But let me see. Is my reset button working on this? I think it's a little far away. There. Let me reset that. I think when it resets, it should do a successful scan. Okay, yes, that's something for me to look at. But the other commands here, you can see I can scroll through my list. If the list gets really long, you may want to start filtering. So I can use this this button here to say, okay, only named devices, only known ones that we've seen multiple times, ones that are presenting as an Apple device. And while we're here on the Apple devices, this is something I showed yesterday. I've got a couple of sets of AirPods here. If I open up a set and take it out, I believe that's what puts that into advertising mode. And that's what this is all based on. This is all based on scanning for advertisements. So let's see, AirPods just showed up. So I can scroll down to those and see if there's any info we can learn about it. Yeah, so the guess here is that it's AirPods. Apple doesn't identify itself as AirPod, but I have the code that I've developed with Claude Code is able to correlate certain advertisement packets and manufacturer packets to try to guess what the device is. So this has iBeacon that is off, apparently. If we go back out to the full list, Let's see, Apple TV and HomePod. Let's see if my iPhone has, let's see, that one there, what that lists. So it's got Find My and Nearby as Apple services that it's showing off. Also, iBeacon turned off. So I don't know how common iBeacon is now. I think they were using it in stores, but I don't know if that's still something that you'll see. But some remnant of it is in the message packet. So the other filter we have here is non-Apple stuff, which right now is just my camera and my light. I'm curious what the camera says. Yeah, so ZV-E10. It's a Sony camera, which doesn't advertise itself as Sony, which is interesting, but I may be able to add that to the list of if it's a consistent manufacturer packet, part of the message there. So this is just saying that it has generic access and its name, and not much else. It doesn't have a second page. Okay. Oh no, I've run into memory overrun again. Okay, so continue to work on that, but I'll put a guide together. Hopefully that'll get in a good enough shape to share, and people can then look at it and see if they want to add to it. Some Nice said in the chat that they are, get rid of that, using the Bluefruit Connect app for Android to discover the Canon camera's blasting Bluetooth even when turned off. Oh geez. Yeah, that's one of the things I noticed about that. There's a video light over there, the Nan light. I don't have an easy way to show it, but it's a small bicolor LED key light kind of light, and with the physical switch turned to off, it was still advertising Bluetooth, which is interesting. So I probably have to unplug it and assume there isn't a internal battery that keeps that running. But I believe that's a light I can turn on and off with the Nan light Bluetooth app on the phone. So it does want to show essentially that it's in a standby mode and it's not truly off. So yeah, I think a lot of things are standby like that, and will advertise their Bluetooth in case some remote comes along or a mobile device comes along. So that's where that is at. I also finished putting together. We can go over here for a moment. I finished assembling the leverless fight pad. I was going to demo for you today the. Oh, let me flip on. 1 second. I'm going to flip on another microphone and turn off that AC. And pop this window up. I was going to demonstrate this in Street Fighter 2 for SNES on an emulator on my computer, and the window didn't want to capture. It wouldn't capture properly no matter what I tried. So I'll come up with a different way to demonstrate that. But I had a little right angle guy in there. Oh, hey, look! I'm in front of a camera that seems to be stuck and not showing me. I walked. Do you notice? Look at this. This is a fun magic trick. If you look at the overhead view, I'm right here. But if you look at that little yellow on the small picture-in-picture, I'm a ghost. What happened there? I'm gonna turn this camera off and on just to see if it. Things are freezing today. I don't know why. I'm invisible. Bizarre. Oh, that's strange. This is, let's see. Yeah, that is a, I just turned this camera off. Let's see if it goes to the, I've been a ghost the whole time. Yeah, that's a frozen view. That doesn't exist. That camera view you're seeing is a camera that's been turned off. I have to refresh that thing. Let's do, how bizarre. Probably has to do with me trying to use my camera as a video camera earlier. Let's do that. Turn the camera on. I may have to disconnect the capture device. Let's see. Where's the 6300? Are you it? No. That's the main camera. Okay, hold on. Aha! I just convinced the little button box. Hey, look, I powered down the button box, and when it came back up, it still has that image buffered. What on earth? Let me turn the air back on because it's starting to get a little warm. Turn off that mic. John Hodge said, creepy would be if the buttons started clicking anyway. Yeah, I'm creeped out. Why is it doing this? Let's go over here. Okay, I'm going to add that device back in. After I power it back on. No, that thing is thoroughly screwy. Huh. I can bring up the chat so I can read it there instead. Let's put main cam. Yeah, weird. That is a camera that's turned off. So that is just some image that is stuck in the buffer. I think I'll bail on trying to fix that because I suspect it is actually Wirecast. My streaming software has hiccuped and doesn't want to refresh that. Let me just make, okay, I'm going to try one last thing. I'm going to make a new shot entirely. And go to that. Nope, same thing. Huh. Oh well. That's fine. I can bring this thing over here. We won't be at the workbench today. So let's go down to down shooter, which is yay, still working. I'm gonna crank that up there like so. Uh-oh. And let me grab that controller. Focus it. There we go. Nice and shiny and sharp. Okay, so this is it, just fully wired now. I've got, we were looking at this last week. I've got the 11 buttons wired up, right? 6, 10, 11. We've got essentially A, B, X, Y, L1, R1. So in something like Street Fighter, these are 3 kicks and 3 punches, or vice versa. Left, down, and right. So you can do all of your combos without accidentally missing stuff with a joystick or accidentally hitting up. If you do want to jump for some reason, go up. Either thumb on that is the up, weirdly enough. This is the start, or what's called S2 inside of GP3040 CE. And to do select, I can hold down that modifier. So the little boot button on the Cutie Pie acts as my modifier, and I've just set up, I think, 2 of these as modifiers, but we could do essentially shift and all of these. Then you've got 22 buttons at your disposal. You can also do combos of things. So like shift and this can be. So if you want to, for example, change the mode from DirectX to X input to switch, that sort of thing, you can have those keys for that. So that's the build there. Just a mess of wires underneath. I'll neaten that up as I put the photos together for it. The other thing I wanted to show, though, is this is, if I can go to the browser here, This is GP2040CE. If we go to downloads, these are the RP2040 based and RP2350 based boards this has been configured for. I was able to essentially use the seed JAW as a starting point and then create my own config for that. And here's what that config looks like. Let me go to my... Let's go back to this for a second. So I'm just going to open up a config that's just the board config.h. And sorry if I showed this last time. I can't remember if I did or not. But this is what I'm using during compile of GP 2040 to say if we're going to run this on an Adafruit QtPy RP2040, then these are the pin definitions, and that's what allows me to use those available 11 pins that you see wired up there. So something like the up button is by default going to be on GPIO 29, which is, I think, the fourth one down from the upper left there, so something like A2 or A3. And I may have, I can't remember if I listed that name. No, I didn't list the silkscreen name on there. But this is all of the key stuff that gets set up, and then in the config itself is where I'm setting the hotkey function plus the boot button to be that first modifier, the select button modifier. If it's in, there are other combos that are just left unconnected here for HID stuff if you're using it in keyboard mode, which I'm not. Excuse me. And the one thing that I hadn't gotten working is while we have a pin on the QtPy that is the RGB LED NeoPixel pin, pin 12, the board requires a power pin, pin 11, to go high, and I haven't been able to get it to do that. GP2040 understands the concept of this, that the NeoPixel pin may need to be powered as well as talked to. So the different pin that acts as the switch for low power stuff, but I haven't been able to convince it to work yet, so not sure what's going on there. Meanwhile, by the way, I am going to unplug that camera capture box that is very hot and not working. We'll see what was up with that later. Okay, so that is the config there, and I'll try to add that to this this set up here. I'll submit a PR with that to see if people will check that out and approve that as another board. You can see there's a lot of neat third-party dedicated boards as well. Some of them are sort of all-in-one controls. Right here, this is a little cap touch one. It's got the RP2040 on it, as well as some cap touch buttons, I believe. I think that one is. Maybe those are for wiring. But some of these are really high, like dedicated fight controller boards that have all of the, as you can see here, all of the screw terminals on it, and a little spot there for Pico to get soldered on, as well as some other connectors for lights and things. Super cool. Okay, so hopefully next week I'll be able to show it in action. I just couldn't get capture working on the emulator that I was running. And let's see, does that bring us to pinball stuff? So maybe I'll even move a camera for that. So this is a pinball machine that I just got. It's my first pinball machine, and I was essentially looking just for some parts. I wanted to build a little demo unit out of a pop bumper or a flipper, something with a couple solenoids in it and some switches, just as kind of a little fun project. But while I was searching for them, I found a deal I couldn't refuse, a very inexpensive, these tend to not be cheap these days, but I found a very inexpensive, used, but pretty decent condition, Williams Space Mission pinball machine, which is from 1975 or 1976. And that's what the back glass looks like there. It's a 4-player game. There was also a 2-player version of almost identical game, except it was called Space Odyssey, and they removed a couple of rows of scoring reels and some related relays, so simplified it a little bit so I could sell that one cheaper. But the one I got happened to be the 4-player. This is what the play field looks like here. It's a pair of flippers, it's got a pair of pop bumpers, it has a spinner, has a couple of out lanes. Interestingly, it doesn't, if you see where I'm clicking right here, it's actually got, instead of, there's often a post here where you can cradle the ball if you want to catch it. You can't do that in this game unless you do like a dead catch on the flipper, because this is a little popper. So when the ball lands just to the left of your flipper, it sits there for a moment and then gets ejected out at high speed towards this swinging target. So there's a constantly swinging target on a motor there, and depending on where it is, when you hit it, you get different, you light up different bonus lights. So the cool thing is, this is an entirely electromechanical machine. So this is what the underside of the playfield looks like here. You can see there are bundles and bundles of wires for these like 8 or 9 relays that are kind of in a row right here. You can't see them that well because we're looking at their bottom side, but you can see here's one of the flippers. Here's another flipper. Here's the little kickouts. There's the swinging target motor right there. So that's all the underside of the playfield. And then inside the cabinet at the base, this is what it looks like here. This is the sort of stepper unit or score motor that is the logic behind the thing. So that runs at a consistent like 27 RPM or something like that. When a event triggers it, it then has little cams at different intervals that cause events to happen at different rates across the field. So it's all relays and solenoids and switches, all of it. There's no microcontrollers or solid state stuff. It's got a really great, super loud set of 3 doorbell chime kind of chimes over here. Bing, 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 bong, 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 bong. And I started to fix it up. It was sort of working, but sort of broken. And I've, without too much difficulty, I've gotten a couple of switches adjusted and lubed 2 motors that actually, most things don't want to be lubed in a pinball table, but there are a couple of spots where there's actual oil wicks where you put a little like 3-in-1 oil into a reservoir, and then it slowly, very slowly over months and months with one oiling keeps some things lubricated. Otherwise, most of it is self-lubricating stuff or doesn't want to be lubricated. Some brass gears that don't need to be lubed. There's a lot of plastic on plastic for the solenoid sleeves. Todd asks a question: how much power does it draw? I haven't put a meter on it, so I don't know. And I'm not sure that the manual says, but one of the cool things is, along with the table, I got the operator's manual and the schematic. And so let me just check. I don't think, like, it's got some nice, you can't see that too well. It's got some nice parts diagrams there for, it's a pop bumper, or as Williams calls it, a jet bumper. Let me go to this down cam right here. Move this out of the way. Since everything is just based on paths of power running through open or closed switches deciding what's about to happen, there are things like this jumper. So you just have a little pin on a wire that you put either in the credit position or the extra ball position, and that's what happens if someone hits the rollover when it's lit for special. Are they going to get an extra credit that shows up on the coin credit reel, or are they just going to get an extra ball? So there's a whole lot of stuff that's just these simple little change the path of which relays will end up closing or latching or opening some switches. So I don't think it mentions anything like power consumption here, is my guess. But let's see. Yeah, so one of the 2 problems, and my good friend Todd Bot over in the chat came over to help me start diagnosing this, and we found that there's just almost all of it's AC, running off of a transformer at 26 volts or sorry, 24 volts or 6 volts for the lamps, incandescent lamps. There are just, I think, the two pop bumpers, the only thing that runs DC. And so they go through a little bridge rectifier, and they have their own amp. There's a fuse, a little 10 amp fuse. There are 4 other fuses for other systems, but this was popped here. So I replaced it and then started testing the pop bumpers to see if it would blow, and sure enough, one of the pop bumpers caused that to blow. So Todd said, hey, let's put a multimeter on that and check the resistance, and it was definitely out of spec. So I've got a replacement for this coil. Which you could have told through visual inspection, probably. This thing is looking weird. I don't know what is the deal with the weird PVC balloon-looking bubbly, blistery stuff on there, but I have a replacement for that one coming that should solve the second pop bumper problem. There's also a lot of, I don't know if someone tried to put graphite or what, but this, I think, is this bushing sleeve should be moving, and I think it's just kind of fused into there. So that's the bad old one. I should have a good new one coming. Abado said 5-cent adjustment. Lol, yeah, this I think can run on 5, 10, or 25 cents, and there's a bunch of choices there to make. I just set mine on 25 cents. Does not have a free play setting, so I'm just going to have a jar of quarters nearby for people to play with. So that's that was the issue with the fuse there. So I luckily I bought like 5 of that particular fuse. So I blew one of them, discovering that yep, there's a pop bumper bad. But now it seems like we're okay. This is a lot of parts numbers here for the different relays and coils and things for replacement stuff. Positions of different jacks. Oop, I just popped that out. These, I may talk about some of these little guys in the future that are essentially used as when a player increments, go player 1 to player 2, 4 or 7 different contacts all change at once to change the scoring path. So we start scoring for the right player. So those are interesting. Same with the match unit, which checks to see if the last 2 digits of your score match the sort of randomly selected, hey, you got 60 and so did I, you get a free play kind of thing. And yeah, so this is a lot of like sort of the principle of play and how things, what causes different things to be energized, which is great. But the other cool thing it came with is the schematic diagram, which looks like this. It is almost as long as the machine itself. And it essentially can be read from left to right, sort of, but I'll hold it top to bottom, which is how a lot of stuff is printed. Yeah, but wait, there's more. So the transformer here, here's the 110 plug. Here is the first fuse of a few up here. Here's the swinging target motor. Here's the game over latching relay. Here's the on-off switch. Colored wire colors are in here. Here's our transformer. So we have 110 coming in, and then we have 24 volt going to all this stuff, and all the light bulbs are on the left here. So those are all the 6 volt things. And then way down at the bottom here, the little DC bridge rectifier and 10 amp fuse, and then the 2 jet bumpers along with you can see their relay names there say DC. Those are the 2 DC things in the whole thing. So this is really helpful, but even more helpful is someone on the internet sort of redid it in color by tracing over it, basically, and maybe using OCR or typing, I'm not sure. But they, let me bring up my viewer of this so we can zoom in. But they've now got sort of computer and human readable text. So you can see that right there has now been, all this has been turned into text, which is great. I don't know if the lines, those must be, yeah, I don't know if in this PDF if those are like vectors or if those are just sharp pixel raster color stuff. But the interesting thing is there is enough info here. Let me rotate this again like I was showing you. So let's go back again to the top. So there's enough info here for an LLM, in my case Claude Code, to study this and the 30 years of Usenet group and forum discussions about electromechanical pinball machines that exist out there. And this space mission was a popular one. It sold over 11,000 units, and then Space Odyssey, another X thousand. And they were very similar to other Williams machines of that time, as well as Gottlieb and Bally and other. A lot of them are running pretty similar methods. So I said to Claude Code, okay, here is a PDF that I think you can look at. I'm interested in creating a sort of interactive flow chart or logic of this system so that I can slow it way down and see when I put a coin in, which relay or relays do what state do they change to. And in fact, if I go to my browser here, you can see, let's go to, okay, so this is my Claude. It's actually Claude AI. I didn't do it in Claude Code even. So this is just Sonnet 4.6. I didn't think it would be that taxing, so I'm not using Opus, whatever. So here's the beginning of my discussion. If you're curious about how I approached it, I said, don't create anything, but answer this question. Using the schematic here as a starting point, do you think you could create an interactive application that allows me to understand how the logic of the system works? Imagine doing something like flipping the master on off toggle switch and then seeing yellow highlights of every switch that gets flipped, every solenoid that's energized, etc. So it got worried at first because it couldn't really read that PDF, but then I downloaded it and sent it to it, and it got much happier about it. It said, great, PDF extracted. That's a solid chunk of the schematics component inventory, which is what leads me to believe it may actually not be seeing the flow of it. So I'm actually, I'll talk about this later, but I'm interested in maybe giving it a real schematic where I know that all the connections are clear and the symbols are meaningful and specific. But from here, you can see this was its first attempt at showing me that in an HTML format. I'll skip ahead to, this is after some iteration, the current version of it. So I think you can see that. And I'm going to make, can I make that a little bigger? If I make that bigger, it'll fly off the bottom. We'll scroll down there. Okay, so I'm going to refresh this page so it starts with a cleared out log file. And if you take a look here right now, I have a speed slider. Oh, did I refresh this? Okay, I'm gonna, let me be a little risky here, and I thought I had, oh no, I haven't, okay. I have it working on clearing up there were some like Unicode or ASCII characters that I didn't understand. So you'll see a little bit of mess on here, but we'll ignore that. But the speed here, I think this is gonna be slower on the right here. If I turn this on, in my log it just says master switch on, transformer energized, the game over relay mechanically latched, and you can see it up here. Sorry, this is a little small, but you can see there's a green dot here saying we have the game over relay is currently energized, but none of these others are. So you've got like a 5,000 point relay, the reset relay, shooter, eject, and so on. If I look on the playfield events here, I can insert a coin. It happens to be set for just 10 cents. So again, I'll press that and you'll see the credit light just turned on. It's going very slow. I should probably speed that up. Player count is set to 1. And I think it's waiting at this point. I'm going to speed this up a little. How many players? This is actually in the real game based on if you put 4 quarters in, you can just play as 1 player with 4 turns of 3 balls or 5 balls. Or you can press the start button multiple times, and that'll create the multiplayer. So I think I can hit start. And you can see the game over relay gets unlatched, the reset relay flips, and that sets a whole bunch of things. The score motor is running right now, and we see on the left here the score motor cams sending impulses. The shooter relay is latched, the flippers are energized and live. I think you can't press the flippers when you just walk up to the table until you've actually got it started, the game started. Shooter coil is enabled, which means if there's a ball sitting there, it's going to get shot over into the shooter lane. So in my simulation here, it's waiting for this ball enters the out hole. So if I press that, it goes, oh, the out hole is energized, just shot that out, ran the score motor. It's all reset to 0. Player 1 is activated, which lights up a little light. Shooter relay is latched, and the flippers are live. And all of that is listed down here in the little event log. So now there's nothing, the game doesn't know when you actually launch the ball, so there's nothing to do there, but it rolls up into the top where it can come down one of 3 lanes. So if I say, okay, we hit a 10-point target, it's going to run the score motor, and it's going to throw 10 points on there, and then I have a little score display here. If I do something like hit 1,000, we'll get a bonus relay advances. So we can see here, score motor, chimes, bonus unit, steps 1 unit. So each time you hit something like a bonus, it'll say we're at 1,000, 2,000, 3,000, 4,000. It'll just step up the bonuses, what'll get scored later when you when you drain the ball. And I can drain the ball just by saying ball enters the out hole. And now it's going to step through and rack the score up. So you can see this is a sort of bare bones version of it. There's a question over in the chat from C. Grover, says, can it produce an animated version of the schematic in addition to the flowchart? That's what I want. That's actually what I was going for first. But then as I was chatting with Claude and realized I didn't think it really understood the schematic fully. It kind of understands the logic better, probably from a priori knowledge of surfing forums and things like that, but it has my parts, so it's able to kind of correlate those, my part list. So I think I want to make like more of a net list of what's connected and try that, so I can get an animated version of that thing there where I can see things light up as they occur. So yeah, that's definitely one of my goals. I also found there's let me make a tab for this, hold on. There's a thing called EMSIM that has not been released, but it does exist. Here we go. Here's a logic circuit animation, so this will show what lights up when either A or B gets pressed based on pairs of open or closed or swizzled switches. So this is the kind of thing I would love to do is have a real circuit simulator or at least a visual circuit simulator, which would be cool. So yeah, that's as far as I've gotten this going, but it's definitely helped me understand some of the more complicated events. I've also got a mode here where I can just step it. So if I do something like turn this on with step mode on, and wait for the next thing. So if I insert a coin, oh, is it not? I don't think it's respecting the step mode. Hold on. I haven't tried this on Safari. I don't know if it has an issue with this. I've been using Chrome as I've been developing this. Step mode is on. Turn this on. Next step. Okay, yeah. So this will allow me to do each sort of discrete thing, and it'll wait for me to advance. So that'll make it a little easier to see some of what's happening. Like I said, I was trying to use the iPhone continuity mode camera so I could show the table, but that wasn't working. So I'll try to get that set up for next time so that we can take a better look at the actual table and some of the things that are going on. And then I may try to pull out just how some of the very specific discrete modules of it work in preparation for maybe doing some non-destructive microcontroller shenanigans, like having a QT Py that can be a score counter as well, or who knows what. But I think it'll be interesting to see what kind of projects are possible using this table as an input without breaking stuff, but just reading inductance or optical stuff or continuity or something like that. So that is what I've got cooking with the pinball table. But it is it's a rich world of interesting stuff with it. Let's see, anything going on in the chats? Oh yeah, so there's a nice little gift from Uniscoop. So nice. I love when the ball gets stuck and it goes through every servo motor or solenoid. Yeah, when you first start it, if you've put in a coin and hit start, the very first thing it does is resets every score reel to 0, and it kind of does them in sets of 5. And so it's just to get everything back out to 0, which is pretty cool. So yes, pinball. All right. I don't think I've missed anything. I think that's what I had for you. Do I have a good way of showing this thing? Before I got started, I pulled out one of our little latching relay, or little latching solenoids, which you can see it there against my shirt a little bit. I just have a benchtop power supply here, which I've set to, I think this one's 12 volts. And you can see there's just a magnetic coil there, just like this one. It's just smaller, that runs off of 12 instead of 24. That's what's happening kind of all over the machine. So I may dive into a little bit of solenoid stuff and magnet wire coil stuff with this. So we'll see. Let me know if you're interested in what your interest is. Of course, pinball has gone far beyond. This was actually among the last of these electromechanical machines before solid state and digital displays happened. And then if you look at the way they are today with stuff from places like Stern Pinball, I think those essentially are a PCB per thing with a CAN bus-like networking system running around. They're incredibly sophisticated and have all kinds of ramps and moving arms and shooters and electromagnets that'll grab the ball out of the air and stuff like that. But this one is quite simple. All right, I think we're gonna end it there. Once again, I'll mention if you want to go and pick up some stuff, maybe pick up some solenoids and make your own mini pinball situation, go to Adafruit.com, use scrolling as your coupon code on the way out, and you'll get 10% off. And I forgot to mention, if you do want to save some more money or spend more money to get more, improve your value proposition, then go to adafruit.com/free to see what the current price break enticements are. We've got, for $99 or more you spend, you'll get a free PCB coaster with the Adafruit logo on it. Spend $149 or more, you'll get the free coaster as well as a KB2040. And if you spend $199 or more, you'll get the coaster, the KB2040, as well as UPS ground shipping for free in the continental United States. Okay, I think that is going to do it. Thank you everyone so much for stopping by. See, Grover said, you know you're a pinball machine addict when you start winding your own coils. Uh-oh. I've already been warned by some pinball people that your first table is going to get lonely real quick and it becomes a problem. All right, thanks everyone so much for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. See you soon. Bye-bye.
Thank you.